In this video, we are going to look at how to find eigenvalues and eigenvectors of a 3 by 3 matrix. As you can see, this is our 3 by 3 matrix, and this is the characteristic equation that we're going to use to find our eigenvalues. So this is the definition of this characteristic. This is our matrix A. This A represents this matrix A, and this is our eigenvalues. And yeah, we further down to simplify down to this matrix, all these rows multiplied by columns, and then we simplify further down to this matrix, and then from there we just multiply this first element with this one, and we get this one, and all the other elements remain, but only this diagonal element change. We subtract the diagonal elements with the eigenvalues here, and our matrix is this one. So from there we're going to further do calculations and find our eigenvalues. So this is how it goes. Just put your hands to find the equation that will give us eigenvalues. Just put your hands like this. The first one is 1 minus lambda, so we'll just select these elements here. That is our first, and remember this will plus, this will minus, so our second, I forgot, this one is 1, so our second try will like this. You will put your hands like this middle, and like this, and the remaining elements will fill this. So 1, we came to 1. Our remaining elements are 1 minus lambda, 3, 1, and 1 minus lambda. Okay, our final one is plus, it's positive, it's 3, and it's 3. We'll put our hands like this to get the final one, this and this. So the leftover elements are 1, this one, this one, this one, and this one. So 5 minus lambda, 3, 1. Let's just leave this one like this. Okay, let's put it to minus 1 times, this is a matrix, so remember for the 2 by 2 matrix we used to calculate cross, this times this minus this times this, so that's the same thing will follow. Let's just this times this minus this times this, so 3 times 1. Okay, no, what, 3, this last one here, 3, so 1 times 1, 1 times 1 minus 3 times 5, 5 minus lambda equals 0. So we further simplify our, so we do the math and we come up with the equation. Let's solve the one in this first. So 5 times 1 is 5, 5 times minus lambda is minus 5 lambda, lambda times 1 is lambda, lambda times lambda is plus lambda square, so minus 1. Let's just this. Okay, this one, we come to this one also, we have to solve this one. 1 times 1 is 1, 1 times lambda is minus lambda, minus times 1 is minus lambda, lambda times lambda is lambda square, 3 times 1 is minus 3. So this one done. Now we come to this one. 3. 1 times 1 is 1, minus 3 times 5 is minus 15. 3 times minus 3 times minus lambda is plus 3 lambda equals to 0. So after I learn working out, our final equation is this one. So we're going to use this equation to come up with our eigenvalues. So let's just punch this equation into calculator and get our unknown values. So mod equation value of a is, oh by the way, this one is a, this one is b, no c, only d. So yeah, our a value is 1, b minus 7, value is minus 7, c is 0, our d value is 36. So yes, that's our x value, or we could just say lambda 1. So lambda 1 is equals to 6, or lambda 2 is minus 2, lambda 3 is positive 3. These lambdas are simply our eigenvalues. So we're going to use these eigenvalues to find our eigenvectors. So 1 for lambda is equals to 6, for lambda is equals to 6, we just substitute back into our equation, this equation. 5 minus lambda 3 1 equals to 0. So we just substitute this lambda value into this, so we will come up with a new matrix. 1 minus 6 1 3 1 5 minus d6 3 1 minus d6 is equal to, so our final matrix after this substitution is 5 1 3 1 1 1 3 1 and 5. So from there we just write it in their normal equation form. Let's say x1 plus x2, this 5x1 1x2 3 3x 3 is equal to 0. That's equation 1. So x1 minus x2 plus x3, this equation 2, 3x1 plus x2 minus 5x3 is equation 3. So from here we can see that this one, equation 1 and equation 3 are similar. The second value is same, so we cannot choose these two. We will choose this equation 1 and 2 to further simplify our calculations and find the eigenvectors. So we just write this again, x3 x1, this one and this one are same, so we will exclude them. We will not exclude them, but we will just leave them out. We will choose this equation 1 and 2 only. So we just say our x1 x2 x3 values are Okay, from here we just solve it like this. From here we'll just do it the same way that we do in the first part to find the eigenvalues. So our x1 values are, we'll just do like this and cross like this. Our x1 value are 1 2 3 1 1 3 1. Our x values, x2 values are, to find the x value we will just place this in the middle, x2, and like this. So our leftover values are 5 1 3 1. So 5 1 3 1. Okay, our x3 value we just place at the x3 and like this, and our x3 elements are 5 1 1 1 minus 5 1 1 1. So that's it. And to make sure, if you want to find eigenvalues for, you follow these steps, make sure you must make sure these two elements are same, these two elements are same, and these two elements are same. So ours is correct. So we go ahead and find the eigenvectors for lambda equals 6. We'll do cross multiplication and then take their difference. So 1 times 1 is 1, 1 times 1 is 1, it's minus, times 3 is minus, so it's minus minus, this minus and minus 3, x2, 5 times 1 is minus 5, 1 times 3 is minus 3. Okay, x3, 5 times 1 minus 5 times minus 1 is 5, 1 times 1 is 1. Finally it's 4, 1 minus minus is 4, x2, 5, 8 minus 8, x3 is 4. So yeah, our x1 is over 4, x2 is over minus 8, x3 is over 4. So x1, x2, x3 is equals to 4 8 4. and final our final simplified eigen values are not eigenvalues. Our final simplified eigenvectors are, let's put 4 outside, and this one becomes 1, this one becomes 2, and this one becomes 1. That's our final, sorry, this one is 4 minus 4, and this is the eigen vector at lambda is equals to 6. So we still continue to 2 for our eigenvalue minus 2. We're going to substitute these two into this one. Is minus minus is plus. Okay, 5 minus 2 is 8. Not 8, sorry, 7. 1 3 1 minus 1 minus minus 2 is 3. So yeah, 3x1 plus x2 plus 3x2 is equals to 0. That's equation 1. X1 plus 7x2 plus x3 is equals to 0. Equation 2, 3x1 plus x2 plus 3x3 is equals to 0. This is equation 3. So as we can see, this one and this one are similar, this and this are similar, this and this are similar. So we will use these two equations to solve for our eigenvectors. So 3x1 plus x x2 plus 3x2 equals yeah, let's just write this again. 7x2 plus x3 equation 2. We choose this equation 1 and equation 2 only, so yeah, let's continue the same steps that we followed in the past to solve for our previous eigenvectors. Sorry, no, it's not 0. It's just 3 1 3 1 7. We just write down the coefficients. 1 is x1, just put the figure like this, and across like this, one way the figure like this, and across like this. It's 1 7 and 3 1, 1 7 and 3 1, x2 x2. This spiral moves to the middle, so the remaining elements are 3 1 3 1. So for x3, this spiral move to the left. So our remaining elements are 3 1 1 7. So 1 times 1 is 1, minus 7 times 3 is 21. That's x2 over 3 times 1 is 3, minus 1 times 3 is 3. So x3 is equals to 3 times 7 is 21 minus 1. So now our x1 value is 20, our x2 value is 0, our x3 value is 20. So our eigenvector is we further simplified it to, let's put this positive 20 outside, and 1 0 1 is our eigenvector at lambda is equals to -2. Finally, we'll find the eigenvector for our final eigenvalue, which is positive 3. So 1 minus this lambda is, we will just substitute this 3 into these lambdas, and we'll get the simplified matrix. So the simplified matrix is 1 minus 3 is just 2. This one we'll just write it down. 1 5 minus this 3 is 2 1 3 1. 1 minus lambda this 3 is 2. So that's our matrix. We'll further write our matrix into its equation form. x2 3x3 is equal to 0. This is equation 1. Okay, x1 plus 2x2 plus x3 is equal to 0. Equation 2, we just repeat the same steps that we followed in the past. So 3x1 plus x2 minus 2x3 is equal to 0. This is equation 3. So we look for similarities. This equation 3 and equation 1. This equation 1 and equation 3 are similar. So we exclude them, we never use them. We just use this equation 1 and 2 because they are not similar, they are different. So let us write this again. 2x1 x2 plus 3x3 is equal to 0. Equation 1 x1 plus 2x2 x3, that is equation 2. So our x1 x2 and x3 values are, coefficient of x1 is -2, coefficient of x2 is 1 3. That's first row. Our second row is coefficient of x1 is 1 2 1. So you'll further Just put your biro like this to find this. So our remaining elements are 1 2 3 1 1 2 3 1. Okay, x2. Put your virus in the middle because it is x2, so we'll just put along the x2 column. So our remaining elements are minus 2 1 3 1. So 2 1 3 1. Let's do finally x3. So for x3, just put your biro on the x3 column, and our remaining elements are 2 1 minus 2 1 1 2 minus 2 1 1 2. So we solve this to get our eigenvector x1. Okay, 1 times 1 is 1, minus 2 times 3 is 6. x2, 2 times 1 is minus 2, 1 times 3 is 3. x3, yeah, x3 not x2, sorry. 2 times 2 is minus 4, minus 1 times 1 is 1. So x1 is equals to 1 minus 6 is 5. x2, 2 minus 2 minus 3 is minus 5. x3, 4 minus 4 minus 1 is minus 5. Okay, so our eigenvalues, eigenvectors are minus 5 5 5, simplified to 1 1 1. That's our eigenvector for lambda is equals to 3. Thank you for watching my video, and please subscribe.